This is section 12.4, part 2. You are doing, the homework will be Big Ideas. You're working in the purple book, Big Ideas, page 436, 1 through 12 all. Okay, I'm going to have to go out of this, so pause it if you need to write this information down. And I'm going to show you in Schoology. So a couple things. For tomorrow's meeting, I would like you to download. I have uploaded the new code. Okay, it's right here. I'm not going to click on it because I don't want to show it to the world. But for Friday's meeting, we are having mandated meetings. I've updated it. You just click on your updates. It should be there with the new code. The other thing I want you to do is to download and print a couple of these, maybe 5 to 6 of these, so you get in the habit of doing this. It just is going to kind of get you in the habit of what we need to do to graph a quadratic. Gathering all the information, it tells you what to do. You can print them back to back. You don't need to have 6 different papers. What you don't use in class, you can use for homework. You don't need to do all your homework on this tomorrow night, but it can just helps to get you in that mindset. There's a lot of steps to graphing a quadratic. Okay, also, now when you go to your courses, on the left-hand side in the tab form, I can't show it because it will have all the Zoom codes. In the left-hand side where all the tabs are, at the bottom should be a Big Ideas. You have access. You click on Big Ideas, go to Launch App, and then you can go to the Big Ideas purple book. All right. So now we're going to get going with our lesson. Today we are doing graphing quadratics. We are focusing on I've got to use this. I've got a flaw in my PowerPoint. We're focusing on finding the axis of symmetry as well as the axis of symmetry as well as the vertex without creating the table and graphing. So before we get started, I have a warm-up. I would like for you to simplify all, evaluate, substitute in, find the value. Okay. Pause the recording and work on these 4 problems. Now let's check our work. This is very important work because this is going to be the cause of a lot of problems of maybe 2 pages of work because of a negative. So I want you to pay attention to your order of operations. We're going to substitute in -3. Here, notice we're doing -3 and we're squaring the whole of it. We're squaring the negative and the 3, and so that makes -3 times -3 is +9. Now here's where everything goes awry. Now remember, x is equal to -3. So that means all of x will be a -3, and so I have to square all of that. Now, where the problem is that kids want to do this. Negative times negative equals positive. The problem there is we're not using our order of operations. Back in elementary school, we called it PEMDAS. Sorry. Okay, now we call it GERMDAS. Okay, meaning we've gotten away from PEMDAS because parentheses, we use all kinds of grouping symbols in high school. So any kind of grouping symbol. This stands for grouping. Oops, sorry, I misspelled it. Grouping. E and R, where before it was just exponents, it's exponents. Or roots. Remember, whatever comes first from left to right. If the root comes first, we do that. If the exponent comes first, we do that. But first, we do our groups. Our grouping can also be a fraction. This creates a natural group. Okay? This is multiply or divide, whatever comes first left to right. And this is add or subtract. Okay? So, problem here is that when you do negative times negative, you're multiplying before you do the exponent. We have to do the exponent first, which is positive 9, then times that negative. It's like a negative 1. And so that makes negative 9. Okay? Pause it if you want to take notes. All right, on the next one, I'm substituting in. Now remember, I'm doing my exponent first. That's a positive 9 times negative 2. Now look here, I've got negative 5 next to the parenthesis. There's no sign there, so it's multiplied by negative 3. Negative times negative makes a positive 15. Now this simplifies to negative 18 plus 15. That makes negative 3. Okay? Trying the next one. I'm going to substitute in. Again, remember, we do exponent, so that becomes a 9 times the negative. This becomes minus 21 and minus 2. Negative 9 minus 21 minus 2. I owe $9, I owe $21, I owe $2, I owe 32 altogether. Okay? Pause it if you want to take notes. All right, so we're going to skip through this first few. One of the things I want you to ask yourself, what is the axis of symmetry? What is the vertex? Who remembers how to find it? Okay. That axis of symmetry is the imaginary line that divides our parabola in half. And since it's crossing the x-axis here at 0, the axis of symmetry is 0. In this case, my axis of symmetry is 0, and my vertex is at 0, 4. All right, this time our axis of symmetry is crossing through 1 in the parabola. It's crossing through 1. So notice it crosses the x-axis at 1. So x, right there, x becomes 1. My axis of symmetry is 1. As well as the x in the vertex is 1. So notice the axis is symmetry and the x is 1. Okay, so now what we're going to talk about today are critical features that are going to help us to graph a quadratic without doing a lengthy table process. So the first thing I want you to do is write down the equation. This is the quadratic equation. Now, when we started in Chapter 6, all we saw was this, and that is what we were factoring, trinomials. Okay, all we're doing is adding a equals y, and because we call the first term a quadratic term, we call the second term a linear term, we call the last term a constant term. That's a term with only a number. All right, now yesterday we talked about what happened with our absolute value functions. Okay, when a is positive, it opens up. When a is negative, it opens down. These are our critical features, okay? We also talked about what happened when we multiplied an absolute value or a quadratic by 2. It made the parabola or the v, it made it narrower or skinnier, okay? So if the number is greater than 1, it makes it skinnier than the parent function. If it is less than 1 but greater than 0, not negative, because negative just turns it upside down, right? It turns it upside down. Positive turns it right side up. But if this is a fractional amount, less than 1 but greater than 0, it makes it a wide parabola. So I would write down there next to your notes right here, I would call it a fractional amount, okay? This is our fractions. Or decimals, same thing. Okay? Pause that if you want to write it. Now my C is my y-intercept. And if it's positive, it shifts the parabola up or the y-intercept up. If it's negative, it shifts it down from the origin. Pause this if you need to take more time with your notes. Okay, so now you don't need to write this right now. I'm going to show you. Now, if I were making the table again, I would just choose my x's. And if I were going to choose my x, I'm doing, negative 3 squared minus 6 times negative 3 plus 2. So right here we're doing, it's 9 minus plus negative 6 times negative 3 is plus 18 plus 2. That makes 27, 29. You can try the same thing with negative 2 squared plus 6, the equation said minus 6 times negative 2 plus 2, that makes 4, plus 12, plus 2, that's 16, that's 18. Okay, and we're going to keep doing that if we want. That takes a lot of time. So I'm going to remind you, let's go back to two of our critical features, which are the axis of symmetry and the vertex. First, what is our vertex? Hopefully you guessed it is, or didn't guess, but you counted over 1, 2, 3. So it's positive 3. And then I go down 1, 2, 3, 4, 5, 6, 7. And since I'm going down, it's negative 7. That is my vertex. Okay? All right, so you'll notice my vertex is 3, negative 7. And my axis of symmetry is also crossing through, that's crossing through 1, 2, 3 on the x-axis. So my axis of symmetry is 3, and that's also the same thing as the x in my vertex. The x in my vertex. You don't need to write this part. Okay. So now we're ready to find our axis of symmetry and our vertex without graphing. Okay, so the first thing we need to do is identify, there's a formula for the axis of symmetry, and I want you to write it every single time you do this. So that would be, you start with the formula, x equals negative b over 2a, negative b over 2a, and so now I have to identify what is my A, what is my B, and what is my C. Okay? So you can see that the A has no coefficient. So really what that coefficient is 1. The A is 1. The B is negative 6. And my C is 2. Now we don't use the C for our axis of symmetry. We're just identifying these critical features. We'll need it later. But for the axis of symmetry, we're only using B and A. Okay, so I substitute in to find the axis of symmetry. So I'm substituting in negative 6, right? I always write my double negatives so I don't lose a negative. Notice the B is negative 6, and we have a negative in the formula. So there's 2 there. Remember, negative times negative is a positive, so 6 divided by 2 is a 3. My axis of symmetry is 3. Now, I'm going to take that axis of symmetry, and remember, that is the x in our vertex. I'm going to then take the original quadratic equation, which is right here. Okay, I'm going to take the original quadratic equation, and now I'm going to substitute the x and in for the x in the equation and solve for y. Okay, so I'm substituting. I get 9 minus 18 plus 2. And then we end up with negative 9 plus 2 is negative 7. So now we have everything we need to write our vertex. The x is 3, and the -7 is the y. That is our vertex. Okay? So basically, I substituted in my axis of symmetry into the quadratic formula, into the quadratic equation to solve for the y, so we could find the y. Okay? I would label this as your vertex. Now, other critical features. I want you to point this out. Even though the book doesn't ask for it, I want you to label these too. First of all, looking at the equation, which way is it going to open up? Remember we said if it's positive, it opens up. If A is negative, it opens down. And since A equals +1, it opens up. The other thing we're going to look at, that's another critical feature, is the C, because the C is my y-intercept. In this case, my y-intercept is 2. Okay, so that ordered pair, remember, a y-intercept, that's where it crosses the y-axis, 1, 2. So anytime it's a y-intercept, how many across do we go? 0. X is always going to equal. So that ordered pair is 0, 2. So anytime it's a y-intercept, x will always be 2 with whatever that number is for the ordered pair. Okay? All right, pause the recording if you need to take more notes. We're going to try it again. All right, so here we go. Let's find the critical feature of the quadratic equation below. So we're going to start with, actually, why don't you pause the recording and see if you can do this one on your own. All right, let's check our work. The first thing we have to do is identify our A, B, and C. My A is -2. My B is 8. And what appears to be C, we don't see a C. So we're going to say that C, since we don't see anything, it's a 0. Okay, so I'm substituting in A, B, and C. So now A is my -2, my B is 8, and my C is 0. I'm going to substitute that in. We ended up with a negative divided by a negative is a positive, so 8 divided by 4 is 2. I now take that and I'm going to substitute it into the original quadratic equation. -2 times 2 squared plus 8 times 2. Now remember we do exponent first. So that's a 4 times a -2 plus 8 times 2. Okay, that's -8 plus 16 makes +8. So y equals +8. So our vertex is +2 and 8. Okay. Tell me about the other critical features. Which way is this going to open? Since A equals -2, it will open down, and the y-intercept is 0, so the ordered pair would be 0, 0. And so that is it. You're working out of the big ideas today. You're doing 1 through 12. Hope you have a great day.